This is 7-4, applying properties of similar triangles. Pause the video so you can try the warm-up, and then you can check your answers. Here are the answers for the warm-up problems. Here's a little blurb on perspective and how it relates to geometry. Let's jump to triangle proportionality theorem. Triangle proportionality theorem says if a line parallel to a side of a triangle intersects the other two sides, then it divides those sides proportionally. So here's my parallel lines. And what we're saying is this is going to create a proportion, like AE over EB is equal to AF over FC. And that's shown right here. Okay, so again, let's use the triangle proportionality theorem. We have two parallel lines. So what we're saying is that RV over VT is equal to RU over US. It sort of divides it for you already. You can almost think of this parallel line as a fraction bar. And so when I write my proportion, I'm writing 10 over 4 is equal to 14 over US, or we could call that X. Cross multiply and solve for US. So US is 5.6. I didn't mean to put a period in between U and S. I guess I'm used to the United States. Okay, use a triangle proportionality theorem to find CY. So again, it's the same idea. We've got, you could say like BX over, we have our parallel lines. So BX over XA is equal to CY over YA. So let's look at that. 4 over 9 is equal to X over 10. Notice this smaller portion over the large portion equals small over large. Since I started with the small, I have to keep it that way. Cross multiply and solve, so 40 equals 9x. Divide both sides by 9. We end up with 4.4 repeating, or 4 4/9, or just 40 over 9. I called it X, but it's really CY, so 4.4 repeating is CY. Okay, well now the converse, sort of like the reverse of this, of the triangle proportionality theorem, says that if we have a proportion, then the lines are parallel. Remember, we used converse theorems before to prove lines are parallel. So if we have that proportion, like AE over EB is equal to AF over FC, then therefore we know the lines are actually parallel. So let's use the converse of the triangle proportionality theorem to verify that these lines DE and BC are parallel. So we're going to set up a proportion. I could do like 10 over 15 is equal to 8 over 12. Cross multiply. Both cross products equal 120. Since these are equal to each other, then we can say that the lines are parallel. DE is parallel to BC by the converse of the triangle proportionality theorem. Now for the you try, if you want to pause and try it first, feel free. I'm going to go ahead and put the answer here for you. So since the cross products equal each other, we can say that MN is parallel to KL by the converse of the triangle proportionality theorem. Okay, and if there's more parallel lines, the same thing happens. We just have lots of proportions separated by all these parallel lines. So they're calling this the two transversal proportionality. Okay, so there's a lot happening here. The first part, they're asking us to use the information to find ln. So ln is right here. So I could use what we know. We know so far we've got AB, and we have KL, and we also have, in comparison to that ln, we have the BD. So I'm basically using the parallel lines. Let me see if I can pick a color that you can see. These parallel lines right here to help me decipher my proportions that I'm setting up. Okay, so I can set up my proportion now. I've got 2.4 over that larger piece BD, which I'm just going to combine the 1.4 and 2.2, so that'd be 3.6, is equal to, we know KL is 2.6 over that whole piece ln. I'm going to solve for ln for part A. So I got the ln is 3.9 after cross multiplying. For part B now, oops. Okay, for part B we're going to find LM. So I'm basically going to do the same thing, except I'm only going to use BC when I set up my next proportion. So I'm going to do AB, which is 2.4, over BC, which is only that 1.4, is equal to KL 2.6 over the smaller part LM that matched BC. Cross multiply and solve for LM. I got about 1.52 once I rounded for LM. Okay, and the last theorem in this section is the triangle angle bisector theorem. An angle bisector, remember it's going to split into two congruent angles as seen in the hypothesis, divides the opposite side into two segments whose lengths are proportional to the lengths of the other two sides. So not including this middle piece, what we're saying is that we have BD over DC, so basically both bases. The base over the base is how I think about it. The ones across from the angle bisector, across from the congruent angles. So base over base is equal to left over right. So if we do like left base over right base is equal to left side over right side. That might help you to remember it a little bit better. So let's apply that right now. So here's my triangle in example 4. If I kind of flip that around, this to me would be the left side, left base right here. This would be the right base, and this would be the right side. So what we said was left base over right base is equal to the left side over the right side. Now there are other ways to set this up and it'll still work as long as the correct expressions are diagonal from each other, but I'm just trying to follow the example that was provided. So I'd have 32 times x plus 5, because we're going to need to distribute, since it's a binomial, equals 40 times x minus 2, and distribute and solve. Once I distribute it and solve, I end up with x equals 30. Now they want us to find PS and SR. So I have to plug that 30 in. So 30 minus 2, which is 28. So PS equals 28. And now let's plug into SR. That would be 30 plus 5. So SR equals 35. And we can check our work and make sure that makes sense. So again, what we said was 35 over 40 is equal to 28 over 32. So I know I can divide both of these by 5, so I end up with 7/8, and I can divide both of these by 4, and I end up with 7/8. Or you can cross multiply, and you'll see that the cross products equal each other. So you can even check your work on these. Here's the you try. At least pause the video and see if you can set up the proportion correctly. I labeled this accordingly to help myself set this up correctly, so I've got left base over right base is equal to left side over right. Cross multiply. Remember to distribute, so it'll be 14 times x plus 2 is equal to 10 times 2x plus 1. 14x plus 28 is equal to 20x 10. Subtract 20x from both sides, we get negative 6x plus 28 equals 10. Subtract 28 from both sides, we get negative 6x equals negative 18. Divide both sides by negative 6, and we get x equals 3. And again, you can plug that in and check.